So in this video, we will be talking about refraction. Now let us understand physically as to what refraction actually is. Say suppose you have two medium. Say this is a separation or this is a line between the two medium. Say suppose this is a medium, medium 1, and this is another medium, medium 2. Now, if you want to take the example, you can take the example of, say suppose this is air and this is water. So now sometimes what happens is that when rays, after striking the surface, some of the rays gets reflected back. We have already discussed this in our chapter of reflection, and sometimes some of the rays passes through the medium into the second medium. So from the first medium it passes through the second medium. But what we see is that it passes somewhere like this. But if you try to draw a straight line, you see that it should have been somewhere over here. But instead, it changes its angle. In a way, you can understand that it changes the angle from the normal. So why is this so? This is the question. And this particular phenomena is known as refraction. This particular phenomena is known as refraction. So you can understand refraction as when light from one medium passes on to another medium, it changes its angle from the normal. That phenomena is known as your refraction. Now, why does it happen? What you can observe is that, say suppose this is a denser medium, or this may be a rarer medium, Now that is optical density. We are talking about optical density and not the volume density. Now optical density, now when we talk about optical density, there is another thing which comes as speed of light. Now we know speed of light is different in different medium. So if the speed of light is greater in this medium as compared to this medium, then this medium is known as rarer medium and this medium is known as denser medium. So now optical density depends upon the speed of light of that medium. How much fast the speed of light travel with accordance to this medium, that is your rarer and denser medium. That is how we define. Now what we see is that there are two conditions that we can observe. The first condition is if light is coming from a rarer to a denser medium, from rarer to denser medium, we see that the angle, that is the angle with respect to the normal decreases. So this particular angle will decrease and it will come closer to the normal. Okay. The second condition is if it is going from denser to rarer medium, that is angle with respect to the normal increases. So this is how you can understand refraction. Now for my second case, what I have taken is, say suppose this is the rarer medium that we have discussed and this is the denser medium. Let this be normal. So if a light which is, say suppose, passing through over here, this is my light, so it should have been coming out like this, but since there is a difference in velocity of light in the two medium and we say this as a rarer medium, we see that there is a slight deviation of the ray, and this is angle theta 2 and this is angle theta 1. So theta 2 is always greater than theta 1 for light traveling from denser to rarer medium. So this is the concept of refraction, and the law which you can see is that sin I. Say suppose this is the light is going from here. So this is sine, this is angle of incidence, or in this case theta 1. This is angle of incidence, this is angle of reflection. For this case, this is angle of reflection. Or this is, sorry, pardon me, this is angle of refraction. This is being refracted. So this is angle of refraction. Angle of refraction, this is also angle of refraction. So sine I, this is angle of incidence by sine R, that is angle of refraction, is always equal to n2 of 1, speed of the medium 2 with respect to 1, or you can say, you can understand this as refractive index. Now we will be coming more into refractive index, but for now what you have to understand, when I write n2 of 1, I am talking about the refractive index of 2, of medium 2 with respect to medium 1. So this is what we can understand from refraction, and this is the law of refraction. Sin I by sin R is equal to refractive index of medium 2 with respect to medium 1. So now let's understand what is refractive index. Say suppose if I am talking about refractive index of say this medium. So what am I actually referring to, and when I talk about refractive index of medium 2 with respect to medium 1? So what actually am I talking about? Let's have a look in our next slide. Now say suppose I say refractive index of medium 1 is say K. Refractive index of medium 1, refractive index of medium 1 is K, say. So basically what I am talking about is refractive index is how much slower does light travel in a particular medium as compared to light traveling in vacuum. That is, if I am talking about refractive index of a particular medium, I just want C, that is the velocity of light in vacuum. Velocity of light in vacuum as compared to velocity of light in that particular medium, So this is what actually is my refractive index. So if you want to find the refractive index of medium 1 with respect to medium 2, what you will have is, for this you have C of V1 by C of V2, which is given by V2 by V1. And I often find that students get confused regarding this term. That is refractive index of N1 and N2. N1 by N2 is given by V2 by V1. So this is actually a vice versa relation. N1 by N2 is actually equal to V2 by V1. So when we look at Snell's law, it was given by sin of I by sin of R is equal to N2 of 1. What does N2 of 1 actually mean? N2 of 1 actually means, this was sin I by sin R, sorry I wrote this again. So N2 of 1 actually means N2 upon N1, that is refractive index of medium 2 with respect to medium 1. That is what we are talking about. And if you compare the velocity, this becomes V1 by V2, because N1 by N2 is V2 by V1, this becomes V1 by V2. So sin I by sin R is also equal to V1 by V2. So this is how you can understand what is N. Refractive index of medium 1 is actually speed of light in vacuum with respect to the medium. So this is how you can understand Snell's law and refractive index.